All right, good morning, good afternoon, good evening, wherever you are in the world. I hope your day is going well. We're here to celebrate three extremely amazing milestones that ICP celebrated last week. We're going to talk more deep into what these three milestones were. I want to first welcome Manu and Dimitri from DFINITY's R&D team. How you guys doing?
Doing good, Kyle. How are you?
It's good to see you guys. So I'm gonna
Good,
ask you
yeah,
guys.
thanks.
Good. I'm going to ask you guys some questions. We're going to dive deeper into what these milestones are. But for the audience at home, essentially, we're going to dive deeper in the R&D side of this for about 10 to 15 minutes, after which we've got 4 ICP OG devs, guys who have been building on the Internet Computer for years and years. And they're going to be here to tell you more about what these milestones actually mean from their perspective and how they're going to benefit. So definitely stick around. We're going to have a phenomenal show for you here today. Manu and Dimitri, let's start with just the Tokamak. So the three milestones, Tokamak, Stellarator, and Beryllium. Let's start with Tokamak. And I just want to first start off by saying Tokamak and Stellarator are, if people aren't familiar, those are particle accelerator names. So it's just totally on brand for us to use a deep in the weeds physics terms to name our milestones. So guys, what was the Tokamak milestone, and what are we celebrating here?
Yeah, maybe I can start, and I'll let Dimitri chime in later. So yeah, you already mentioned the names, right? Tokamak, Stellarator, and Beryllium. I think in some tweets we use simpler words, namely speed, storage, and simplicity. And so Tokamak is about speed, and I guess in particular about latency. So we want that, you can build anything on the Internet Computer and run it as a secure software running on the protocol. And of course, for that, one thing that's important is that it's fast, right? You don't want to wait for a long time. You don't want that anything running on the Internet Computer is much slower than things running on Web 2. And so the goal of Tokamak was to reduce the end-to-end latency for users as much as we can. And as you nicely see on this roadmap page here, that kind of had 3 main ingredients. The first was that we, so this is a distributed protocol, as you know. So any message that you send as a user, and if you click a button, your browser sends a message to the Internet Computer, this needs to go to different replicas that all process that message and agree on an answer to get the security that we're looking for. And so this networking we changed. We based on the quick protocol, made latency lower, therefore the blockchain can grow faster, and that reduced latency. Then we also changed how messages are sent to the system, and we made the routing between boundary nodes and replicas geographically aware. And overall, this essentially cut the end-to-end latency for users in half. So that's a very significant improvement.
We tend to use this word latency. Can you give some background for the audience in terms of like what latency means for them if they're using an ICP app?
Yeah, so let's say you want to vote on a governance proposal, or I don't know, like you log into the NNS front-end app, and you might click the vote to adopt button there. And what that does is now your browser is your agent. It sends a message on behalf of you to the Internet Computer, to the governance canister. And that now needs to be ordered in the blockchain, processed, and then the result needs to be certified, and you get that back. So all the way from me clicking that button to me seeing a trustworthy response from the subnet that my vote has been counted, that full duration from clicking the button to seeing the results, that is what we call the end-to-end latency.
I love it. So really like a better user experience. I think early in the internet days, and there's this guy who kind of caught on to the internet really early from a marketing perspective, and he'd always say you have like 1 second to convince your user of your app, as in like your app better load in less than a second, and the first thing they see better hook them. And so latency kind of is all about that, right? Leveraging like keeping them interested in the application and not getting tired of waiting, right?
Yeah, exactly. And actually what we see now is that, so now on a regular subnet, if it's not like overloaded or something, we see that typically the latency is on average like 1.3 seconds. So this full end-to-end thing where this message goes across the world and the replicas all agree on it and process it and sign the result, all that happens in on average in 1.3 seconds, which is like getting close to the point where it's like, yeah, you don't really notice it anymore.
Yeah, that 0.3 seconds is not going to make a difference. In the, I think Bjorn Tokman had a great tweet recently that basically said, now we've achieved Web 2 like experiences and you get it for free. Is that, do you kind of agree with his sentiment?
Yeah, exactly. That's definitely the goal. So you want that. Yeah, I mean, the goal is that more and more software runs on the internet computer and benefits from the security properties and transparency and availability. But you don't want to pay like a big penalty in latency or how nice it is to use the DApp, right? You don't want it to feel sluggish. And I think there we now made a huge step forward.
Yeah, awesome. I love it. All the benefits of blockchain, none of the decrease in user experience is a great place to be for a protocol. Let's move on to Stellarator. Give us the background on what Stellarator was.
Regis, do you want to go first, or shall I continue?
You can continue for now. I think you're doing a good job.
I'll take this one. I'll let you do Beryllium. So I think with Stellarator, it's all about growing like how much memory or data your on-chain app can work with. So yeah, today when we think about smart contracts, we still often think about maybe like limited, quite small programs dealing with some tokens and some financial things. But if we want to move, if we want to allow more and more software to run on chain and benefit from these security properties, then you also want to be able to want to support applications that need a lot of memory or a lot of state. And so with the Stellarator, we made a lot of improvements there. So now you see that the limit, the amount of memory that one smart contract can use has been raised to 500 gigabytes, so half a terabyte. We also made it easier to get states in your canister smart contract. So we significantly improved the throughput with which you can send messages to smart contracts on the internet computer. We did that by changing how they are stored in the blockchain. So no longer, we don't have the full message there anymore, but we agree on the messages asynchronously and then agree in the blockchain just via the hash, which allows it to go like 3 times. We have more than 3 times the bandwidth now than we used to. And we made it easier also to upgrade your dApps that use Motoko. So we have enhanced the orthogonal persistence in Motoko, which makes it even easier to work, to have a lot of memory there and upgrade your dApp in a way that you don't need to like serialize all your state and read it back. And under the hood, what enables this is how the replica holds all this state of all these canisters. So we now use log structured merge tree storage layer, which is I guess the detail is not that important, but it allows the replica to more efficiently handle large states and not have to do a lot of work in one go, but it can kind of like gradually work on it and process the changes that happened without blocking anything. And so this allows us now to store a terabyte of replicated storage on each subnet, so a terabyte of canisters and their memory, which is also great for like a tokenomics perspective, right? So now each subnet can do more work and burn more cycles, which is a nice thing.
I love that. Increasing like the practical max capacity of each subnet is awesome. So walk me through, what is the difference between stable memory and replicated storage? We got half a terabyte for stable, 1 terabyte for replicated.
Shall I take it? So yeah, the first is.
I can also reply if
I'll let you take it.
Yeah, I mean, yeah. So I think the way to think about it is like your stable memory is what you would typically call like your persistent data in Web 2, you know, kind of like a database. It never goes away. After canister upgrades, it's still there. And then replicated state includes other types of memory, like the heap, which, you know, will go away when you upgrade your canister. And it's kind of like temporary data that is alive for the runtime of the canister. But of course, it also includes some other stuff like, you know, message memory, you know, memory that can be used for canister to canister interactions and stuff like that. So I hope that kind of gives like a basic idea of what's like stable memory specifically, and then replicated state is like includes stable memory, but also some other parts, right?
Kind of like on a PC, maybe you have like your RAM, and then you have like your typical hardware data or hard drive data.
Yeah, correct. It's I think a good analogy to think about. Yeah.
And so maybe to summarize, the 500, so the half a terabyte, that's per canister smart contract limit, and then the 1 terabyte is a limit per subnet. So, right. So under the hood, we scale by having this concept of subnets that are each their own blockchain, and so one is a limit per canister, and one is a limit per subnet. And so if you try to have if you want 1 smart contract, then your limit is now half a terabyte, and behind the scenes, you can only have 2 of those on the subnet now.
I love later on we'll get Byron Decker up here because I remember like a year ago Byron and I were talking about storing data on the internet computer, and he pointed out it's great to store a lot of data in a smart contract, but if it takes forever to load it or to download it, that maybe isn't as helpful. And so I love that you guys focused on both the speed and the capacity for data storage. Walk me through. So like for the people who are perhaps unfamiliar with the internet computer, who are watching and they don't really know how to benchmark these, for a typical blockchain, like, do you know by any chance, like how, like, are we talking megabytes? Are we talking gigabytes that a typical smart contract can store?
I don't have the precise numbers, but I think in a lot of places it's more kilobytes or potentially megabytes, and definitely not gigabytes. Or at least if you want to speak of like anything probably beyond kilobytes is like prohibitively expensive in a lot of places. So I think here you see a lot of the architectural choices that ICP made, right, with not going too crazy on the replication and trying to maximize, like don't have too many different nodes powering a subnet, but have them be as distinct, as different as possible. And these things help enable such large numbers for a reasonable price.
Gotcha. It's so you're talking when you're going from kilobytes to gigabytes, you're talking 6 orders of magnitude there, which is just really kind of insane. In terms of so like how much memory is like 500 gigabytes? Talk to people in terms of Bitcoin state. Is this Bitcoin's been around for 16 years now? Is it about the same amount of data that the entire Bitcoin network is at this point, or the Bitcoin ledger?
Because we have this Bitcoin canister that stores all the valid unspent Bitcoin outputs. I think we know that this is roughly 100 gigabytes. So that easily fits into a single canister smart contract. I think the full Bitcoin blockchain is currently, I think, slightly more than 500 gigabytes, maybe 600 or 700 or so, which recently took a big turn with since the ordinals and things like that. But so that's kind of the order of magnitude. So it's the whole Bitcoin blockchain is in that order of magnitude.
Got a good question here from Freddie H. Was there any impact to asset canisters? We noticed the cost of an asset canister cycle consumption went down by a lot. These two things seem perhaps unrelated.
That's interesting. So I think impact on asset canisters is definitely that, I guess, you can now store more in it and you can upload things faster with this milestone. So asset canisters are definitely impacted. The cost, I'm not 100% sure where that comes from. But definitely the other two.
Awesome. All right, so let's go over to Beryllium, and Dimitri, I want you to take us home on this one. I got to scroll all the way down. You guys are working on a lot. That's for sure.
That's true.
Beryllium. All right,
right,
give us a lowdown on Beryllium.
Right, I'll keep it short. So Beryllium is all about developer experience and making things simpler for the canister developers on the IC, right? So we added some really great features that I guess people expect when they come from a Web 2 background and they're used to have backups for their services, logging, infrastructure, and all of that that's coming kind of like out of the box on these kind of platforms. And so with the latest additions here, ICP protocol is also enhanced to allow you to take snapshots of your canisters, which can act as backups of your data. We have canister logging, which you can use to add some logs, debug when things go wrong, or there's an error and you want to see what exactly went wrong in your logic, right, in the canister. And on top of that, we also improved some of the error messages that were sent back to the end users to allow them to more easily understand what are the options to fix an error, or maybe include some link to our documentation with some examples or ideas of how you can go around the issue or how you can fix the issue. And also, I think one big pain point for people was, these panics and traps that they would get, which were like, okay, I just trapped somewhere, no more information. But now with backtraces, you actually do get a backtrace, which does help you pinpoint where in your code actually you hit the panic, and then it's easier for you to figure out what went wrong, right? Hopefully. So I think this kind of summarizes already what we've added. And by the way, there was a video that I made last week where I kind of go through a fictional example using all these features and showcasing what people can do. I'm also, interested to hear what people have in mind for their dApps or what they plan to do. But yeah, there's also that video that you can consult and get more information about these features.
I mean, I love it because, developers are our customer, the ICP's customer. And so these are all just great to improve the experience for developers. Would you mind if you drop the link to that video in the comments, then people will be able to chase it down as well?
I'm not entirely sure if we've posted it publicly yet.
Oh, okay.
So, but I guess we'll make sure that people have access to the video once it's live. Yeah, I think it was in post-processing. So, yeah.
I got you. So good chance to plug our DFINITY Dev Twitter handle or X handle. So keep an eye out for that. Awesome. And there's probably no one better to comment on really like whether like the impact of this milestone than the developers on the Internet Computer. So we've got 4 phenomenal, they're OG developers. They've been around forever on ICP. And so these are the guys who are going to really be able to tell you whether or not this is improving their life, their user experience, their developer experience. So Dimitri and Manu, I just want to thank you guys for your time. Feel free to stick around or head off. Looking through the roadmap here, I know you guys got a lot of work to do ahead of you. There's no rest for you. So I appreciate your time. Let me pull up back on stage. We got Roman, we got Austin, we got Jordan and Byron. Gentlemen, how are you guys doing? It's good to see you guys. So let's jump. I'm going to go around the horn here. We'll start with Jordan and move in a somewhat clockwise manner. George, just start us off with what you're working on and like what you've been building on the Internet Computer.
Sure. Also, I apologize. My voice kind of went out today. So my company is called Demerchant Labs. Basically, if you boil it down, we're building the JavaScript and the Python environments on the Internet Computer. So the whole purpose is to bring traditional normal languages that, regular web or, whatever you call Python developers are, bring those people over and let them just use all the tools that they're used to using. Pull packages off NPM, pull packages off PyPy, etc. Yeah, so that's the main purpose, main goal. And we're getting very, very, very close to the release candidate for the 1.0 version of ASL, which is the TypeScript and JavaScript SDK. We're putting it through extreme amounts of testing. We're doing, normal unit end-to-end type tests, but also property tests and fuzz testing. So getting to the later stages of that. Hopefully we get a 1.0 out in the next month or two.
Awesome. Something to look forward to. And at the end, I'm going to ask you guys to each give where can they follow you more. So definitely plug that later on, Jordan, and give people a chance to where they can keep up to date on the 1.0 release. Austin, give us background. You wear many hats in the ICP ecosystem. So I'll let you kind of pick which hat you want to focus on.
Sure. So I'm the executive director of icdevs.org, where we try to produce resources and build things that promote the internet computer ecosystem, and that helped developers onboard to the ecosystem. Also a founder at Pan Industrial, and Pan Industrial is a enterprise focused consulting and development firm that goes into enterprises and helps them onboard to Web3. We're an integrator for Origin Foundation, and we're exploring with a number of different enterprises how to leverage the IC in the enterprise space, and lots of fun stuff going on there. A few other skunkwork projects and advising Origin Foundation and things like that. So I've been doing a lot of different things.
Love it. But you're one of the originals as well. Roman, give us some background on what you're building.
Yeah, so I'm Roman. I'm working on the IC4J project. So it's basically IC Internet Computer Java agent, which allows any Java application or any Kotlin or a Scala application to connect to Internet Computer. Our goal is not just to bring a basic agent, but also fully integrate the ICP into like Java ecosystem and into like all these popular Java frameworks like Spring and Spark and Gradle and so on. So that's something what we really working on right now. It's also bring ICP into popular Java development tools like IntelliJ or VS Code Studio, where developers can just pick any canister, ideal from any canister, and generate the necessary classes to invoke that canister from their Java applications, or integrate directly into their Java Spring applications. So that's our goal. As the Java is the #1 language in enterprise space, so we have really high hope when ICP is gonna be picked by enterprises and governments. That will really bring a lot of attention to integration with their Java applications.
I love it. I love both you and Austin mentioned the idea of enterprises adopting ICP, and that's something that you're not going to see that on crypto Twitter as much. We're typically focused on like consumer facing apps, but ICP has a role to play on enterprise as well. I love that. And then Byron, give us some background on Cyclops.
Yeah, so I'm Byron. I've been working on the Internet Computer since early 2022. I'm the co-founder of Cyclops. Cyclops is essentially proactive automated cycles monitoring and management for the Internet Computer. And we've been running Cyclops for almost 2 years now, I think, with zero downtime, essentially providing canister metrics and analytics and all sorts of insights to developers and keeping their canisters healthy and running. And our goal and vision for Cyclops moving forward is to build a powerful, essentially a wide variety of DevOps abstractions on top of the protocol primitives that you may have seen in Beryllium and some of the other developer protocol primitives that are coming out soon, to provide a seamless not just canister monitoring, but also management platform that developers coming from a Web 2 or cloud-based background, they might expect or sort of be used to that type of experience. And they can just get up and running right away. And currently we monitor a variety of applications on the Internet Computer, from SNSs like Origin to Dragon, Sonic, and now KongSwap. We also monitor a number of DFINITY owned canisters as well. And then we monitor other ICP applications from funded to NFID and even Discover. So we're pretty excited about a lot of these updates on the developer experience side. And then also I'm excited to talk about a lot of the performance improvements and storage and all sort of the things on the compute platform, because that's had a huge impact on our service and how we decide to scale.
Love it. I was reflecting today, actually, before this, about how one of the least appreciated parts of the reverse gas model. So if for anyone watching that's not familiar, on ICP, the developer pays the cost of hosting the application as opposed to the user, which is more, in most crypto gas platforms, it's the user who pays. But one of the differences is, so reverse gas models like an AWS or a Google Cloud or a typical internet experience, but with the additional benefit that it's not just the developer who can pay the cost, because if the developer walks away, anyone can load cycles up into any canister. And your guys' platform is a great example of that. Of, hey, it makes it real simple for a user to come along and be like, this application needs to keep running, or this smart contract needs to keep running, and I'm going to pay the cost to keep it going, or you can crowdsource the funding of it. So kudos to you guys. That's a little reflection from earlier today for me. Let's go, Jordan. Let's go back to you. I'm very curious for Demergent Labs. What, so we've summarized speed, size, and developer experience. Like, which of these 3 milestones do you think is like the most important for Demergent Labs and your mission?
I don't know. I think they're all pretty important. I think personally, the one I'm most excited about is, let's see, where is it? I believe it's in, Stellarator. It says improved consensus throughput and latency achieved through not including full messages, but only their hashes and other metadata in blocks. I think the significance of that is a little bit hidden. Right now, my understanding, and Manu and Dimitris can correct me if I'm wrong, but my understanding is that has been turned on in only a very basic form, and it's improving throughput, which is very nice. But something I'm very excited for is the eventual ability to increase the limit of the size of the messages. That's correct, Manu and Dimitris, right? Eventually, we will be able to do that from that improvement.
Maybe, yeah. I think we can, like, this enables us to go at least bigger block sizes, even though they're not so cute in the block. And then we can consider bigger messages. I think there's different paths we can take there. But yeah, it is an improvement in that direction.
Yeah, okay. So yeah, hopefully. And this kind of, in my mind, a few months back, I published, and I've been thinking a lot about certain, I called them crucial weaknesses of the Internet Computer Protocol. Things that I think like we must overcome to start to get to a developer experience on par with something like Amazon Web Services. And there's kind of 2 ways to think about ICP. Either it's, a blockchain, which it's already in many ways more capable than other blockchains. It makes some trade-offs on replication and decentralization and robustness, in my opinion, but it is much more capable in storage and compute, like 1000x those resources. That's one way to think of it. Another way to think of it, though, is comparing it to existing cloud platforms, right? Just normal, web hosting and web application or cloud development. And if we want, blockchain singularity, or basically to be able to put the world's software on a decentralized computer like ICP, there are some things that are in the way of that. And one of those things is the message size limit, which right now is, generally speaking, 2 megabytes. So every time you send a request, you can only fill it up with 2 megabytes, which is difficult to deal with as a developer, because what if you want to upload, for example, a 1 gigabyte file, or anything over 2 megabytes, right? So yeah, I'm hoping that we're laying the foundation to increase the size of that limit. Manu said, maybe. So I think people probably, and I don't think I understand it either, how incredibly difficult it is. This is an entirely new computing paradigm in the entire blockchain, like the entire blockchain space. This is a new type of computer, a decentralized computer. So things that are dead simple to do, or at least relatively straightforward in cloud computing, when you basically have single instances, and become very difficult to do if you want to maintain extremely high levels of Byzantine fault tolerance. So anyways, the message size limit, I'm hoping that can be increased eventually. Also, one of the other crucial weaknesses I mentioned was high latencies. If you pull up internet computer applications and it feels generally slow as you're logging into things and doing stuff, that's not a good experience, as we've talked about. The decrease in latency from everything we're discussing is very encouraging. I think that's excellent. I don't think we're there yet, especially because sometimes it's still like a second or two. And when you when you do cross canister calls, when one application basically talks to another in an update call, those latencies stack on each other, sometimes linearly. So, we need to overcome that. But yeah, DFINITY is attacking various of these, in my opinion, crucial weaknesses from a variety of angles. And so Azel and Kybra, the CDKs, from my understanding of these new features, it's not really going to change the APIs of those. Those will just kind of stay the same, but everything should just be faster. You can now store 100 gigabytes more than you could in the stable storage. And also, yes, one crucial thing, the canister snapshots I'm extremely excited about because especially Azel and Kybra, they're experimental. Azel will hopefully cease to be experimental soon, but we're always going to maintain an experimental branch where we can just put the craziest stuff in. It makes me feel very comfortable that we can now tell people, hey, just take a snapshot and then upgrade at will. It almost it doesn't matter as much as it did before. So I'm excited about that.
I love that framing of like these milestones are building blocks for even the future. And when you think about the fact that even a product as a behemoth like AWS had, it was built off of decades and decades of research on various protocols that made up the internet. And even still, when it launched, I think in 2006, it was a pretty bare bones product and slowly built up to what it is now. And so it's good reminder of you can't build Rome in a day, and each of these milestones builds up to another milestone. And so kind of keeping that moving forward. Austin, give us from your perspective, especially wearing all these different hats within the ICP ecosystem, which milestone stands out to you as particularly useful?
Well, I think first of all, the speed improvements have been noticeable already, and those are fantastic, right? And those are great, especially everybody's mentioned already, right? From a consumer standpoint, having the UI respond and having your functions execute more quickly and give you that response back is fantastic. But most of my focus and experience is back sort of on the developer side. And Jordan mentioned it, but the canister snapshots are huge, right? So when you're trying to attract a developer community, you have to do a number of things really well, right? Like you have to give them a place to contribute, right? They have to be permissioned to contribute. You have to have really good dev tools, right? If you make it's almost like on the consumer side, you have 1 to 2 seconds. With the developer, you've got 10 minutes for them to stand up something that works on your platform, or you lose them, right? So and DFINITY's done a better and better job of dev tools. But when you actually get to production, the internet computer is a little, I wouldn't say it's weird. It's just different than other blockchains, right? Other blockchains, you deploy a contract and it's there forever. So there's actually a lot of stress involved deploying it initially. The internet computer gives you a little bit of wiggle room because we have upgradable contracts, which are great. But they're great. They give you more responsibility. They put more transparency, responsibility on the developer. But they have this moment where you're upgrading your production contract on a Friday afternoon, and you know that you're about to lose your weekend or be able to open a bottle of champagne, and it is incredibly stressful.
You're deploying contracts on a Friday afternoon?
Sometimes you are told to deploy a contract on a Friday, and you say, we don't like to deploy contracts on Friday, and you're told you're going to deploy this contract on a Friday. And when you do that, you're about to lose your weekend or maybe get to open a bottle of champagne. But if something goes wrong, you're in deep trouble, right? So before, you had to sort of design your own way to pull the data out. I'll leave the projects nameless, but there were strategies at certain points where it was like, let's pull the data out. And it's like, well, how do we get the data back in? let's worry about that if something breaks, right? And so you know that, okay, if it does break, you're going to have to write a lot of code very fast to load the data back in. And so being able to take a snapshot of your canister before you run an upgrade is like, I can't even describe what an immense load off of your shoulders that is. Because if it's Friday afternoon and you're being told to deploy, you can take a snapshot, you can deploy, and if everything crashes and burns, you can call your boss back up and say, something's wrong, we're going to have to wait till Monday, and they're going to be upset, but at least you didn't go, like, you were only down for like 5 minutes because you redeploy the snapshot and everything picks up where it was before. So to me, from a developer experience, that is huge, and it takes away this huge concern for developers that if they've looked at the platform and are evaluating platforms, that was a big concern for a lot of folks. There's no way to back up, and we're getting better logging from the canister, and a bunch of other stuff that are sort of wrapped up in these improvements are huge to me. And I think it's going to make going to production easier. People are going to be able to go to production more often with more confidence. So that's great.
I really appreciate that answer from the perspective of developers are humans as well. And even though crypto's 24/7, developers don't want to be working 24/7, and just the simple quality of life adjustment of being able to easily revert back a change is really helps them free up their weekend to do the things that they like to do. So great. That's a great perspective there, Austin. Thank you. Roman, let's jump over to you. Same question. In terms of these milestones, like which one were you kind of looking at and thinking, oh, this is actually particularly useful for what I'm doing?
Yeah, so first it's gonna be more work on my plate because, in our agent, we will have to support like V3. So that's something we'll be starting to work on, already doing some research and see how it's gonna fit on the other side. We will really want to have like that API on the Java side really clean. So that's probably the most of work. It's think about how that it's gonna translate into the experience in the Java. But very excited about that one. Like latency, it's always important. The payload size, absolutely. We moving to this AI space where we're trying to upload these large models into canisters, and where the models will be gigabytes of size. So we really want to have enough space for this type of operations. And of course, in enterprise space, you might face a lot of large data payloads where you will process images, binary files, documents. So that's something what is really critical to basically improve on that side. I'm really particularly excited about lifecycle operations and especially logging. If you are a developer or if you are in the operations, if you don't have a good visibility in your system, then you are like driving blindfolded. So and it's not just for development, it's also for operations, where if you go to any like large enterprise organization, you cannot individually try to analyze one simple canister or one operations on the canister. So you have a procedures and you have a tools to basically analyze where the problem happens. So if we have a good API to basically be able to extract those logs and analyze them and be able to pinpoint certain situations where it happens, and maybe do some even predictive analytics where we can analyze if these situations happens too often or so on. We can really make the entire system or applications built on ICP much more robust, efficient, improve performance, and so on. So something what comes after we deploy applications operations, because that's the boring part where oh, that's exciting, we're gonna build some stuff, but then you have to like maintain these operations for years and years and years, and you will have people who are not original developers who will have to understand what's going on under the hood. So I'm really excited about, the ICP is moving to be really something, again, to be this enterprise space first-class citizen, where we can really fit into environment. And, in our project, we have also kind of ICP management package for Java, which enables you to do lifecycle directly from Java, talking directly to canister APIs. Basically, you don't have to use the UI provided by ICP, but you can directly, for example, deploy, undeploy the canisters from your Java application. So it might be completely invisible to end user. Now, I don't even know if I'm using ICP, because that application is doing this stuff for me. And we also have plugins for popular frameworks like a Gradle or Maven, where the developers or organizations using ICP can plug ICP lifecycle into their existing tools to do operations or lifecycle management, because you have to bring ICP to environment what they already using. It's not gonna be other way around. You have to go to General Motors. If they want to use ICP, they will ask you how we can plug ICP into our existing environment system. And I think these are all steps to right directions, and hopefully utopia will eventually come and will more address the issue of how we can be more attractive for enterprise and government customers.
Roman, you're doing a great job of just giving me lots of ways to plug different DFINITY objectives at this point. You mentioned AI, you mentioned utopia. Let me, Roman and I actually met in person, it was either 2 or 3 weeks ago at a Web3 and AI conference in Palo Alto. And one of my big takeaways from that conference, Roman, was you have a lot of people who see potential in combining Web3 with AI, but they have two needs. One is the fact that blockchain technology can be complex, and then AI technology can be complex, and now they're trying to layer the two together. So you have layered complexity. And then the second one is they need to be able to iterate pretty quickly, because they're still not totally sure on what the product truly is, and they're trying to iterate to find product market fit in a rapid fashion. What you mentioned and what Austin mentioned in terms of the logging and the ability to take a canister snapshot to give confidence is really all about that, iterating really quickly, and being able to maybe try different things out, and if it doesn't work, pivot pretty quickly. So I think AI and Web3 in that specific vertical maybe will benefit from these two or from these 3 milestones. And Byron, if I can kind of round it out with you, I'm hoping, being a data guy, I know you were the founder of CanScale, which was a phenomenal data product on the internet computer. I'm hoping you have some insight in terms of the size upgrades, but if not, feel free to take the question wherever you want. Which 3 milestones are most impactful for you?
Yeah. Well, I mean, there's so many different parts of these milestones that impact what I've been building. I guess in terms of what I'm building right now, I'll get into the storage a little bit, because that's actually a very important part as well. But in terms of what I'm building right now, with Cyclops, we need to monitor, a lot of canisters, and we do it all at once. So latency and message throughput is really key for us. And one of the things that may not be mentioned directly in these milestones, but I think is just as important, is there were a lot of scheduler improvements that were made to handle a lot of the load that the internet computer has received recently. And those have made a huge impact in terms of the perceived latency and throughput from an individual canister's perspective. And so, you as a user may not see it, but us as a developers, we feel it. We feel the difference big time. And you as a user may also see it as well. And yeah, Kyle, you brought up sort of the upload download speed. And those improvements around, storing the message hashes, and instead of like needing to store the full messages, those also apply to us. We've seen the time that it takes for our monitoring to run halved recently, which includes monitoring canisters on the European subnet, also known as the Bob subnet. And this is directly related to those improvements in Stellarator. Message throughput, and since all of our monitoring runs at the same time, we receive a whole bunch of metrics back at the same time from a bunch of different subnets. So this is an area in terms of upload and download, at least from canister to canister, that has made a huge difference for us. And then in terms of the storage aspect, that's also, I believe, in Stellarator. Stellarator is a pretty massive, some pretty massive compute improvements in there. But an important part of our service is enabling us to provide these historical and like time series type of analysis for charts and predictive analytics. And so we have, time series cycle chart burns and memory charts that we provide developer teams. So in the recent release, right, we saw canister stable memory, which is up to 500 gigabytes. Now, I'm a big Motoko developer. Austin's also a Motoko developer. There are, if you're a Rust developer, or I guess Azle as well, then using stable memory is a little bit easier. There haven't been those types of affordances in Motoko that are as easy to use. So Motoko developers are really excited about Motoko's new orthogonal persistence feature. And this is essentially going to allow, Dimitri's talked about heap memory and stable memory. So apologize if I'm getting a little bit in the weeds here, but stable memory essentially persists across upgrades. Heap memory is volatile, it gets wiped. So developers need to, essentially migrate their data to stable memory before an upgrade and then back afterwards. And this is time consuming, it burns cycles. If you can imagine, if you have a lot of data, it's going to take a long time to serialize all that data and have it back. Motoko's new orthogonal persistence feature allows essentially you to keep that data in heap memory, and it will persist across the upgrade. And heap memory also has performance advantages over stable memory as well. So this is like a really big deal for Motoko developers coming out. And the goal is, and the hope is that with WASM 64 coming out, which will allow the heap memory of a canister to be expanded to essentially infinite memory, or whatever the hardware handles, this heap memory limit can be lifted over time and will achieve parity with that 500 stable memory gigabyte limit. So then you'll just be able to upgrade your canister instantly with 400 or 500 canisters of data. That would be pretty amazing from a developer experience perspective for Motoko developers. So we're really excited about that. Once that happens, we can start storing a lot more historical data and surface that to customers. We can onboard a lot more customers with that data. We can, store a whole bunch of logs coming from canisters, a whole bunch of potentially more snapshots and other tools as well. And we don't have to spin up a whole bunch of canisters necessarily to do that as well, which is nice. And then I think that's pretty much it from my side. I'm excited about a lot, but yeah.
I love that you brought it back around to the fact that for you, it's all about new products and new services for your customers. And these upgrades allow you to basically take what you've already done and supercharge it. So I love it.
I have one more thing I actually just forgot I wanted to talk about, which is Austin covered canister snapshots. So I think that's great. Really excited about that and helping revert changes. But now we have canister logging as well, which helps you go in and diagnose what may have happened in your canister over time. So you get transparency into what's happening as it's happening. I know this has been very helpful to see, oh, my canister trapped, what happened? And also we have canister back traces on top of that, which is like a stack trace inside of your canister when something traps and goes wrong. Super helpful. And like looking forward, what I'm also very optimistic about is canister lifecycle hooks. which will allow you to perform an action when an error happens in your canister as well. I don't know if anyone had insights on that as well, but canister lifecycle hooks as a future improvement on top of all these features, they sort of layer on top of each other and the benefits they provide.
I love it. Love it. Well, let's land this plane. I want to give you guys each a chance to let people know. I mean, each of you are talking about taking these milestones and making use of them. And so I want people to be able to follow and keep up to date on your projects. So Jordan, if I start with you, just where can people learn more about Demergent Labs and keep track of yourself?
Usually my Twitter handle is best, LastMGS. If you follow me, I usually tweet our updates. And then basically everything we do is on GitHub. So github.com/demergent-labs. And you can go see basically 100% of everything we do is open source. So you can follow everything we do.
Well, if you want to make the viewers' life easier, feel free to post it in the comments. You can see the ability to post in the YouTube and X comments on the right ribbon in this application. Austin, give us where can people follow you and what you're doing?
Sure. So they're on Twitter at AFAT. ICDevs has a Twitter as well, ICDevs_org, I believe. Same for GitHub, ICDevs.org, I think all one word is where we put a lot of stuff up there. Just reach out. We're currently doing all kinds of stuff around Motoko audits for code. We're building, hopefully about to wrap up this Motoko EVM project. We're just finished up a big grant, DAO-based grant that if you go to the forum, I'm on the forum all the time. That's probably the best place to find me because I'm always posting stuff over there. But lots of stuff that we pushed out lately and some exciting stuff that's coming in the next month or so as well.
Awesome. Thank you. Thanks, Austin. And then Roman, where can people find you?
Yes.
And what you're building?
I'm quite active on Twitter. So we have this Twitter account, IC4Java, where we're doing like official announcements about products, about new features, everything what comes out new. And then there is a @Skelton one. That's my personal kind of account where I'm talking about discussing the ICP plus some other areas. And of course, the GitHub IC4J. Unfortunately, IC4J was not available on Twitter, so I have to use like IC4Java, which is actually good. But on GitHub, it's IC4J, GitHub/IC4J. And a lot of the code there, so samples. So feel free to, if you're working on Java applications, Android applications in Java, Kotlin, go to GitHub and learn how to use our agent.
Love it. Love it. And Byron, land this plane for us.
All right, I'm gonna try not to crash. I'm Byron. I'm at CanScale on X, and you can find. I've been building a lot of tools at Cyclops on X. We're excited about some updates we have coming in the next month or two. Also, if you ever need to top up a canister, whether it's a canister you own or an NFT canister that just froze or something that you want to support, you can go to icptopup.com and use any wallet on the internet computer to send cycles to that canister.
I love it. I love it. I want to thank you guys so much for your time. Manu and Dimitri, I just want to thank you guys for basically being two-man team, right? Building out all these milestones. I know you guys both have teams behind you doing work, but phenomenal milestones. Jordan, Austin, Roman, and Byron, I want to thank you guys for your time and for all the products and services you've been building on the internet computer throughout the years. And everyone watching at home, I just want to thank you again, and we'll see you for the next milestones, which I'm sure will be just around the corner. Enjoy your day.
Thank you.
All right. Thanks, everyone. Bye.